Okay, hello everybody. Welcome to CISC124 week 3. The topic of today's, meeting is basically the Java for loop, which works a little bit differently than it does in Python. And I'm also talking about assignment number 2. So I'll get you started on that, hopefully, to make your life a little easier. All right, so some announcements. Oh, the agenda today, there are some announcements. I'm going to talk very briefly about the for loop because you have the Jupyter notebook describes it in plenty of detail. And then, as I mentioned, I'll talk about assignment 2 a little bit. So for the announcements, there is a quiz next week. There will be details about the quiz and some sample quiz questions coming soon. So just check on Q on Thursday or Friday, and you should see a practice, sample quiz questions anyway. I don't know if it'll be exactly like I can't promise you that it'll be a sample quiz, but you'll see questions that, will look like ones that you'll see on the quiz. I've got a question already from Lucy. In the assignment, is it okay if the red eye fixing alters reds? Yes, it is. It does not need to be able to recognize eyes. So I'll get to that when I talk about the assignment. But yeah, trying to get it to not change pixels, to not change pixels that are not just in the eyes is actually quite difficult to do. Okay. Now, most of you, I guess all of you, should have taken CISC121. I suppose it's possible there are some of you who have not taken CISC121 because you've gotten some sort of transfer credit. So anyone who knows what a Python for loop looks like, the Java for loop, when you see it, is quite different. But it turns out it's very similar. You just have to get used to mapping what the Python loop does for you into what the Java loop requires you to do. The Java loop requires the programmer to initialize some kind of loop variable. You have to state the loop termination condition, and you have to state the loop update expression. The Python version of the for loop does all of this stuff for you, right? That's one of the reasons why people say Python is an easy language to use, because it does a lot of stuff for the programmer. Incidentally, Java is supposed to be one of the reasons Java was created because at the time it was created, the other large programming language, the other large object-oriented programming language was C++, and C++ had and still has the reputation that it's very hard to use. So Java was meant to be one aspect of Java was that it was supposed to be an easier version, an easier language than C++ to use, right? Python is supposed to be an easier version than, an easier language than Java to use. But it turns out all the languages have their own pitfalls and traps that you can fall into. And none of them are really that much easier to use than the others. They're all just different, right? Okay, so this is what the Python loop actually does for you, right? So when you use a range for a Python loop, right? So a Python loop that uses a counter typically uses a range object, right? And so this range object counts from 0 up to, but not including n, right? So for I in range 0, n, you've got the loop body here, right? Python does a bunch of stuff for you, right? So what Python does is it creates this range object 0, 1, 2, 3, 4, 5, 6, 7, 8, up to n-1. The first time in the loop, the value of I gets initialized to 0, right? The loop body runs, right, as long as I is less than n, as long as the condition I less than n is true, right? So again, in this loop here in Python, right, it runs for every element in the range, right? And the range goes from 0 to n-1, right? So one way to think about how this one way to think about the condition where the loop runs is that as long as I is less than n is true, the loop body runs, right? Every time you reach the end of the loop body, you pop back up to the top of the loop, right? So at the end of each loop iteration, what this thing does is it goes to the next element in the range, right? And so for this particular range, you can think of Python as simply setting I to be equal to I plus 1, right? So the first time this loop runs, I is 0. The second time it runs, it's 0 plus 1, 1. Right? The third time it runs, it's 1 plus 1 is 2, and then 3, and then 4, and so on, and so on, and so on, right? So initialize, right? Loop condition, update condition, right? These are the three pieces that the Java programmer needs to write him or herself, right? So to translate that loop into Java, right? There is your loop initialization, right? So what is the value of I the first time the loop runs, right? Semicolon. When should the loop run? Well, as long as I is less than n, semicolon. What do you do at the end of the loop? Add 1 to I, right? So you can write this as I plus plus. You can write it as plus plus I. You can write it as I equals I plus 1. You can write it as I plus equals 1. Right. So there's at least 4 ways that you can write that update condition, and they're all the same, right? They all do the same thing. Most Java programmers will write I plus plus or plus plus I, right? It doesn't matter which one you pick in this case, right? But all 4 work, right? And it doesn't really matter which one you write. However, in a professional setting, that's what you'll probably see. Okay. The other difference between the Java loop and the Python loop, again, is the braces, right? So braces in Java, they delimit what's called a block of code in Java. And so the loop body in Java is just the block that's inside of the braces, right? And that would be equivalent to the whatever's indented in Python, right? So that's all you have to do to map from this to this, right? It's just the Java loop requires the programmer to spell out all of the conditions explicitly, you will sometimes see examples of loops where these conditions, where that condition and the update expression are more complicated than what they look like here, right? So, for example, that condition here, it's anything that evaluates to true or false, right? So it might be some sort of method call. Right, it might be some very complicated arithmetic expression, but it can be anything that evaluates to true or false. Right? And similarly, that update condition, that update expression can be considerably more complicated. Right. So, for example, if you wanted to make it slightly more complicated, if you wanted to count in steps of 2, that would be I equals I plus 2, or I plus equals 2, or something like that. Right. So you can make these expressions. You occasionally see loops where these expressions are very complicated. Right. But the simple Python loop is translated into Java like this. And for the assignment, this is all you really need, more or less. Right. So let's talk about the assignment. So if you haven't done the assignment yet, or if you haven't looked at the assignment yet, basically everything in this assignment requires you to write nested pair of loops, or I guess there's one of the questions, I think one requires you to write 2 nested pairs of loops. So you write 2 nested for loops, and then somewhere else you write another 2 nested for loops, right? I suppose it's possible some of you will come up with different ways to answer the questions, but the obvious way to solve the problem basically involves nested for loops. And in this assignment, basically what you're doing is you're doing some simple image processing. Right? So you get an image and you do some image operations. And I'll show you what all the answers are supposed to look like in a second. Right? So basically what happens in these images, so an image is just, let me open up the assignment. It's a little easier if I do it that way. So an image here. Right? So there's an image of the Queen's flag with no logo. Right, an image is just an array. It's just a 2-dimensional array of what are called pixels. Each pixel is a color. Right, so this pixel is the color blue. That one's the color yellow, and that's the color red. The image, the rows and the columns are labeled with a number. right? So it's just like it's basically just like a list in Python or a nested list in Python, right? So this would be row 0, right? Row 1, row 2. This is row 5, right? That's column 0, column 1, column 8, right? The height of the image in this case is 6 pixels, right? And the width of the image is 9 pixels, right? So just like a list index, right? The smallest index is 0, and the largest index is 1 minus the height in this case for the rows, right? And it's 1 minus the columns, the width, sorry, for the columns, right? So this is basically, it's basically an assignment that asks you to loop over the elements of either a nested list, a 2-dimensional nested list, or a 2-dimensional array if you know what the array is. You should know what the array is because you should have read the notebook by now for arrays. But you don't actually have to go use the square bracket notation to get to the individual elements because there's a class that takes care of that for you, right? And basically you're processing images that look like this. So so let's suppose you wanted to copy this image, right? So you have a picture that represents this image and you'd like to make a copy, right? Then the way you would make the copy is you need to copy each pixel from the source image into the copied image, right? And so the way you do this is you'd start by copying, well, one way you might do this is start by copying the first row, right? So I'm going to start at column 0 and row 0. I'm going to get that pixel and I'm going to copy it into the source or into the destination image, right? Then I'll go to the next pixel in the first row and copy it into the destination, and then the next pixel, copy it, and then the next pixel, and so on and so on and so on, right? And then I might go to the next row and do the same thing, right? Copy that one, put it into the copied image, copy that one, put it in the next image, right? And so on and so on and so on, right? And you do that for each row, right? And so what you end up with is a nested pair of loops, right? For each column and for each row, right? Copy the pixel at the current column and row, right? And that's just a nested pair of loops, which is what the slide is supposed to be, is trying to tell you, right? So the outer loop simply loops over the columns of an image, right? In other words, it moves left to right. The inner loop just loops over the rows of the image, and that moves you from top to bottom in the image. And so let me show you what the assignment should do. Right? So this is the solution. So if I run this, this is what you should see when you run the program when you run the program. So even if you just download the starting assignment, this is what you should see. Right? You see a picture of a young woman. She's got red eyes. This is because the picture was taken with flash on an older camera that doesn't have any fancy image processing built into it. Right? If you click on the actions menu, there's a bunch of actions that you can do. Right? So the starting assignment can actually generate the Queen's flag for you. Right? And so the method is there that actually generates the flag, and you can look at the method and see how it works. Right. The other actions, these all work on the original image. So for example, copy will copy this image and show it over here. Right, so that's what you should see. Add a border of width 1. So that's going to take this image, it's going to copy the image, and then it's going to draw a border in blue around the outside of the, inner edge of the image. Right, and so it's a little hard, it's probably hard to see over Teams, but there's a 1 pixel border around the image. Right, that's a 5 pixel border around the image, and then that's a 10 pixel border around the image. Right. Grayscale. So the grayscale will take this image and convert the and produce the grayscale or the black and white version of the image. Right. Whoa, sorry. Okay. Binary. So binary is going to take the dark parts of the original image and show them in black. It'll take the lighter parts of this image and show them in white. Oop, right? And you can change the colors. So the assignment actually asks you to create a method where you can pick, the programmer can pick the 2 colors, right? and it tells you that when you hook in the code to show the image to pick the colors black and white, right? But you can play around with the colors and use different colors. Flip vertical should flip this image vertically. So the top row becomes the bottom row. The second row becomes the second last row, and so on and so on and so on. Right, there you go. Right, so over here, the left, what looks like her, yeah, I guess what looks like her left eye in the computed image is actually their right eye in the original image. Right. So you just so that, yeah, that eye is that eye, that eye is that eye. Flip, rotate, we'll take this image and rotate it clockwise to the right by 90 degrees. So you should get that. Remove red eye. Okay, so one of the questions asks you to remove the red eye from this image. Right? And it asks you to, the way the question is phrased is it kind of implies that it should only remove the red eye, the pixels that are inside her eyes, but that's not exactly true. The question says it's okay if some of the pixels that are not in the eyes get changed. Right? So here's my red eye removal method. Right? The question says set all the red pixels. Anything that you think is a red eye pixel, you should set it to black. And that's the result you get. There's a very simple solution that generates this picture. So you don't have to come up with something very convoluted, right? So in other words, you don't have to try to figure out, okay, this eye has, you shouldn't say this eye has is found at this row in this column of the image, and this one's at this row in this column of the image, right? And I'm only going to change those pixels or something like that. It turns out there's an easy way just by looking at the colors that you can figure out what is a red eye pixel, right? And there's a second image as well that you can test it on. So there's a cat picture that has a similar red eye effect. Blur. So blur will take this picture and blur it with what's called a box blur filter. And the assignment tells you what a box blur filter is. Right? You can see that this is a slightly blurred version of this image. I don't know how well it shows up over Teams, but as you increase the what's called the radius of blur, this image will get more and more blurred. Right? So when you get up to 5 pixels, you can see it's quite clearly blurred compared to the original. Right? And it turns out all of these actions here, right? It looks like there's a lot of them, but these 3, they're all the same, and these 3, they're all the same. Right? It turns out all of these you can do with just a simple pair of loops, maybe 2 pairs of loops for the border. But yeah, you can do them all with a simple pair of loops. And so the assignment is really trying to get you to, it basically has 3 purposes. It's trying to get you to work with Java loops. It's trying to get you to work with Java if statements. And it's trying to get you to get used to working with objects and calling methods on objects. Right? And the objects that you have to use are very simple. Right? So I've made them simple intentionally. The class that represents the image is called picture, and it only has like 3 methods, I think that you 3 or 4 methods that you can use, right? So it's very simple. Similarly, the class that represents colors is also very simple, right? You only need to know how to get the red, green, and blue parts of the color, and that's it. Okay, so let's look at the actual assignment. So this is the solution. I'm going to close this because we don't want to show you the solution. And so when you open this up, what you'll end up with is this class here. You don't need to touch main. You can if you want to. So here. So this is a little bit different than the updated version of the assignment because the updated version of the assignment works. It fixes a small bug that some of the students reported. If you wanted to use the cat image, you just uncomment that and comment out in the first line, and then you get the cat. Right. So there's the cat. There's the second image that you can work with. Outside of main, you only need to. What you need to do is you need to add some methods here. And after you add each method, you're going to change the process image method. So the process image method is the method that responds to the user picking a menu item. Right. So when the user picks flag, right, this method gets called, and this part of the method runs. Right, the part that says case flag. Right. So that's the flag command. When you run the copy command, it's this part that gets run. Right. When you run the border command, so a border of pixel width 1, you need to insert some code here that calls your method that adds the border and then shows the computed image. Right. So all of your all of your cases are going to look something like this. Right. So P is the picture. Right. You're going to call one of your methods here. So here you'll call the border method, and then you'll say A2 viewer set computed P. Right, and that will change the picture in the viewer to your new computed picture key. Right, all the cases here will look the same. I can't fill them in because I don't know what you're going to call your methods. Right, so you'll have to fill it in yourself, but it's not hard. The copy method, I started for you in the assignment. Right, so this is the method that's supposed to copy the original image and show it as the computed image. So here's copy, right? It says complete the method. Let's start this method. Now, if you go up to the flag, method, you can see how this sort of works, right? So that image there is going to be the result, right? So I'm going to make a new picture, right? The picture has width 300 and height 200, right? So 300 pixels wide, 200 pixels tall, right? If you need the width of the image, you can get it like that, right? So image.width, round brackets, that gives you the width of the image. You can store that in an int variable w, right? Or width, or whatever you want to call it, right? Image.height, that gets the height of that image, right? And so you can store that in an int variable. Here I call it h, right? The way the flag picture works is it paints in each color separately. So the flag method here creates the image that's 300 pixels wide by 200 pixels tall, and it's blank to begin with. So everything's black to begin with. And then it fills in the blue stripe. Right? So how does it fill in the blue stripe? Well, it starts at the left-hand side of the image and goes 1/3 of the way across the image, right? So that's the first loop, right? So for each column starting at 0, right? As long as the column is less than 1/3 of the image width, right? At the end of the loop, add 1 to the column, right? So this will go across the image, right? 1/3 of the width, right? Each time you move across the image, right, it's gonna fill in the vertical stripe of the image. So what it's gonna do is it's gonna start at the left-hand side and it's gonna paint the stripe going from top to bottom. Then it's gonna go to the next pixel and it's gonna paint the stripe going from top to bottom. Then it's gonna go to the third pixel and paint going from top to bottom. Right, so how do you go from top to bottom? Well, you just move over the rows, right? So for each row starting at 0, as long as the row, that's a mistake, is less than the height, right? Add 1 to the row at the end, right? That explains why there's a black stripe at the bottom of the image. Okay, I didn't catch that when I wrote this, right? And then you can set the pixel at that column and that row to whatever that color is, right? And the assignment tells you how to use the color class, right? That one just makes the color, that's the Queen's blue color, as far as I can tell, anyway. Right? And so that fills in the blue stripe. To fill in the yellow stripe, it's the exact same code, except you change which columns you're going to loop over, right? So you're going to start at 1/3, right? The column at 1/3 of the width of the image. and you're going to go up to the column 2/3 of the width of the image. Right? And then for the red stripe, you're going to start at the column that's at 2/3 the width of the image and go up to, but not including, the width of the image. These -1 should all be, shouldn't be there. I don't know why they're there. Okay. And so to paint the stripe, to paint the flag, there's 3 sets of nested loops. Right? Now to copy a picture, well, the first thing I do is I make a blank empty picture. Right? How big should the picture be? Well, it should be the original, right? That's the original picture P, right? So it should be that wide. So how wide? Well, the width of P. So that's P dot width. How high should the image be? Well, it should be the height of P. So that's P dot height. Right? And I've now got a picture, the result, that has the right size. Right? And now what do? Well, I copy the pixels from P into the corresponding locations in result. Right? So I write a loop for int call equals 0. Right? I want to start at the left-hand side of the image. I want to go all the way across the image. Right? So I want to go up to and not including the width of the image. Right? Each time the loop runs, I want to go to the next column. Right? So increase the column by 1. Right? And now what do? Well, I want to go up and down the rows. Right? So for int row equals 0, right? Starting at the top row. Right? How far do I want to go? Well, I want to go across the total height of the image. That's P dot height. Right? Each time the loop runs, I want to go to the next row. So I add 1 to the row. Right? Now, how do I get the color or the pixel from the original picture P? Right? Well, the way you do that is, right, you make a color variable, give it whatever name you want, C, C-O-L, color, whatever, right? C is nice and short. And I just call the method called get, right? And Eclipse will actually suggest stuff for you, right? So if you write P, period, and wait a second, it'll suggest a bunch of methods that you can use, right? If you hover over get, you can get the documentation over here, right? It tells you, it returns the color of the pixel at that column in that row, right? Which is exactly what I want, right? I want to get the color of the pixel at that column in that row, right? And now what do I want to do? Well, I want to take that pixel color and I want to put it into the result. So result dot, right? Well, what method here will set a pixel in the image? Oh, there's one right here, right? Sets the color of the pixel at column and row to the given color, right? So column is the column index, row is the row index, and color is the color. So set row, what color? Well, C. And that's it, right? When you're done, you return the result, right? So I don't need these. Save, right? Okay, now I have to hook in the process image method, the call to the copy method, right? I've already done that for you, right? So whenever the user selects copy, you're going to call your copy method. You're going to pass in the original method, the original picture. The original picture is just a2.orig, right? And that is defined up here, right? We don't really talk about fields until part 2 of the class, of the course. So you don't really know what these things are yet, right? You can think of these things as just being variables that you can use in the class, right? So there's this thing called orig that you can use anywhere in any method in the class, and there's this thing called viewer that you can use anywhere in the class, right? They're static, right? They're both labeled static. So when you use orig, you normally want to say a2.orig. When you use viewer, you normally want to say a2.viewer, right? But if you leave the a2 out in this assignment, it doesn't matter. So it's already hooked in, which means once you finish copy, you can just run the program. And whenever you run the program, you should close the original one, the one that's running, if there's one here. Okay, so now when I call copy, I should get copy, and in fact we do. Right? If I run the flag, the stripe's gone at the bottom. I don't know if you noticed before, there was a black stripe at the bottom. If you call any of the other ones, nothing will happen because none of the other the cases that correspond to each of those actions, they're all blank, right? So nothing happens, right? And that's how you can, that's how you basically do assignment 2, right? Each one of these methods, or each one of the uniquely named methods, each one of the uniquely named cases basically corresponds to a method. It might correspond to 2 depending on how you choose to implement it, right? So you're allowed to make extra methods if you want, that's fine, right? But border 1, border 5, border 10, those should all call the same method. They should pass them 1, 5, and 10 as a second argument, right? So make a border of width 1, make a border of width 5, make a border of width 10, right? Don't make 3 separate methods, right? Because you'll end up repeating yourself, so don't do that. 2 gray is a separate method, 2 binary is a separate method, flips a separate method, rotates a separate method, right? Blur 1, 3, and 5, those should all be the same method, right? You'll call blur orig, comma 1, blur orig, comma 3, blur orig, comma 5, right? That's the way you should do it. Okay, right, so remember, so add a method, right? Make sure you return a picture each time. Make sure these ones are all static for now, right? Later on in part 2 of the course, you'll learn what happens when they're not static. But for now, everything's just static. And after you fill in the method, make sure you come into the case and fill in the appropriate case so that you actually call the method. Okay, Hudson says, for the border methods, do you replace the pixels of the photo with the border, or do you compress the photo? No, you don't compress the photo. You just, the question tells you what to do, actually. Copy, add a border. Okay, so to add a border of thickness t pixels, begin by copying the input image, right? So begin by copying. So, well, public static picture border. Sure, let's call it border. Picture p int t. Well, let's call it thickness. Right. So this is going to add a border of that thickness to the outside of the picture, right? To the inner edge of the picture, right? This one's a little different than the previous one because it tells you to start by copying the original image, right? You have a method that copies the image here, so you should just use the method. So picture equals A2 copy P, right? And now you just modify result, right? At the end, return. Oh, so here, so I added in the border method, right? So down here, I can go ahead and add in the code to call it A2 border, A2 orig, thickness. So this says border thickness 1. So go ahead and do that. And then just copy that line here to set the picture in the viewer. Right? And once I've done that, I can actually run. And hopefully, if I've done everything right, when I click border, I get a copy of the image. I do. Right? I don't have the border yet because I haven't written the code to fill in the border. But now you fill in the border here. Right? And filling in the border is not terribly difficult. Is it okay if the red eye recognizes some? Yeah, it's okay if the red eye recognizes some pixels in the background. So when I showed you the my solution, it doesn't look like any other pixels were changed, but in fact some of them were. It's just you can't notice it when you actually look at the image. So yes, it's okay. Now, all of these questions are good, but they're all answered in the assignment, right? So if you go and look at the red eye question, it says right here, your method might incorrectly change pixels that are not in the eyes of the person or the cat, right? And that's fine, right? Hopefully yours doesn't change so many that it's noticeable, but it might, right? It might. And for example, if there was like a red ball in the background, you should expect it to change the red ball, right? So if you go and get some extra images from the internet and stick them into the project and try them out, right? You'll easily find images where your method breaks, right? There's even some extra information down here, right? So if you use there are like machine learning algorithms that will remove red eye from images. And basically the way they work is they recognize people, and then they can isolate the eyes, and then they can focus the red eye removal only on the eyes, right? But that's way beyond assignment 2 in CISC124, right? Yeah, way beyond that, right? Okay, so one of the problems students have in CISC121 and CISC124 is actually not programming. Right? Probably the biggest problem students have is not reading the question carefully. Right? And this happened in CISC124 and CISC235, so the data structures course, on the exam. Right? The exam questions spelled out everything that they're supposed to do, and students would do something completely different, which was strange, right? So they wouldn't even answer the question that was asked. So one of the things you need to learn is to actually read the questions carefully, because the chances are the information that you're looking for is in fact in the question. Right? But that's it. That's all that I have for today, or that's all that I was planning on talking about for today. I just wanted to make sure that you can get started on assignment 2 without too many difficulties. I think I fixed the problems that some students are running into. Some students were running the program and the image wouldn't show up. That was interesting, but I finally figured out what was going on there. And so if you get a more recent version of the assignment, that problem has been fixed, so it should run. Okay. Any other questions? Anything? Going once? Going twice? Going 3 times? Okay. I mean, so that's it. That's all that I have for today. Next week, I'm not planning on doing a meeting because you have a quiz on Wednesday. And so, so I wasn't planning on doing a meeting on the quiz days. So there won't be a meeting, but there will be a quiz, and there will be information about the quiz that will appear on OnQ in a day or so. All right. Okay, I guess that's it then. I'll post a recording of the lecture to OnQ within an hour or so. And that'll be it. Okay, thank you, everybody.